An extremely important part of compositing 3D scenes is the ZDepth channel. Now, working with ZDepth in View can be a little different than in other applications, and there are some limitations as well. So first thing I want to do is just create a little bit of a scene for us to take a look at how the ZDepth works and some of the different image formats and some really important aspects of how ZDepth should be saved. Now what I'm actually going to do is just create a standard terrain instead of that procedural I just had. Make it a little bit larger, and we're just going to create a fairly simple scene with some different levels of depth. And I just have kind of the default surface being made and geometry. That is, of course, created randomly. If I edit the object, we can go through this standard terrain, and in the lower right, click New, and kind of go through a couple of different options in order to basically cycle through the fractal that is generating this terrain. I'm going to increase the resolution, and once we do that, it'll also generate something a lot higher detail and use more of the fractal. So we have some good elevation here. I'm not really going to worry about modifying it too much within the editor because we just want a basic scene. Also lighting doesn't really matter too much, but I am going to bring the sunlight by going to Atmosphere, Atmosphere Editor, selecting the Sun tab and changing the pitch of the sun, lifting it higher into the sky, and then we can rotate the sun around the scene just to make it a little more interesting. Okay, so now we have a couple of different elevation areas, something pretty straightforward. And now, since one of the most amazing features of Vue is the ecosystems, what I'm going to do is double-click on the terrain, preview the material, and add an ecosystem layer. Now I just have a really basic grass material currently loaded on. We can see that the scale is currently at 100. When I select ecosystem to add the ecosystem layer, that is going to reset that scale of that material. Now if we select the material layer, we can see the scale is 1, and the overall scale is also 1. This is a layered material, so we just have 2 layers, and they're both working with independent scale. So I'm going to go back to the grass and just change that scale back up to 100. And that way we don't lose the scale we currently have. And I'm going to go ahead and add in a plant. And I'm just going to select something from the shrub collection and just use number 16. If we go ahead and just do a standard population, not going to be using dynamic population, we can increase our density, and we just want to cover the terrain. Increase our sampling quality, which is going to evaluate the altitude and slope ranges a little bit better. And in the environment tab, some of the settings have been automatically applied. This has to do with the layer underneath. Since this grass layer had an environment tab originally, these settings are retained within that material layer. So when I added a material on top and the environment tab becomes available, which is also available for other materials as well, then that information was carried over from the underlying layer and applied to the ecosystem. So what I want to do is reduce that fuzziness for the top, which will create a fall off from the highest point of the altitude. I'm going to increase the altitude range and adjust the slope range a little more, and also that fuzziness option. and repopulate, and we're pretty much going to cover the terrain almost completely. And if we expand these options all the way, we'll be able to create a complete cover. So now we have about 5 billion polygons in the scene, or that will be rendering, not necessarily 5 billion showing in the OpenGL, since we're using the billboard mode to preview the ecosystem. And I am just going to scale this up a little bit, make a few changes, and repopulate. Always making sure to repopulate after any changes are made. And since I just want a really quick render, because the ZDepth really is only going to show certain areas of the scene, we don't really need to worry about the lighting. So I do want to go to the Light tab and turn the lighting model to standard. This does have a rather large impact on the look of the scene. We can see it's not nearly as dark as it was. But I'm not really too worried about that. One thing I'm going to do is go up to the render options up at the top, right click, and I'm going to select just the final render mode. I'm going to be rendering this to the screen for now, which will include an alpha, ZDepth, and color channel. And then we'll take a look at the multipass options and gbuffer in just a minute. So I'm just going to render this to the screen. We could also render it to the disk, selecting a file on the hard drive we'd like to save it to, but I want to take a look at the format options and show you what's really going to work best. So I'm just going to select a fairly small image size, just 800 by 600, and go ahead and render that out. Or actually, I will go ahead and just increase that scale a little bit more. Let's do 1024 by 768, and then we'll go ahead and take a look at that render. Okay, so now we can see the color pass. We could also switch over and see the alpha. And we have a couple little tabs up here on the top and buttons you can click to either zoom in. And keeping in mind that once you zoom, it will condense the window size and you cannot really change the scale of that. So go ahead and zoom back out. And at 100% it will show something a little bit better. And then we have the color pass, alpha, and then the ZDepth. Now, each of these channels can be saved separately by clicking on the save icon, where we just have this little disk. The other buttons we have are for displaying the multipass and gbuffer. Since we don't have that option on right now, it's currently grayed out. And then you also have the ability to go through the gbuffer layer. We can see the arrows moving forward and back. And then there's also post-render options. So what I want to do is save out a couple of formats for us to look at. So we can click on the save icon, making sure the Z depth is shown. And what it's going to automatically do, now that's not currently showing up on my screen, but what it will do is take the scene name and add an underscore Z if it's the Z depth, or an underscore A if it's the alpha channel. And I've added just replacing the name of the scene with terrain, and then after Z I've done an underscore 01. So let's take a look at some of the different format options. And what I want to do is save some more popular formats with different bit depths. And we can take a look at these different files in Photoshop and really understand how the ZDepth works and how to get the most and the best resolution out of the images. So what I want to do first is select just a basic 8-bit image, so we can use a bitmap. So now we have the bitmap saved, and I'm going to go through and also do an HDRI, and I'm going to save these incrementally. And then I can also move down to the TIFF format. And with the TIFF format, we have the ability to save either 8-bit or 16. So let's do both. Do the 16-bit, and also go back. We'll do a -2 on this, and do an 8-bit, using the compression. Also the PNG format. And I'm just going to go through, save a few more out. So we'll go ahead and switch over to Photoshop. And when you close out the render window, when you have it set to render to screen, you can bring back that render at any time. If you go to the top and select the channel within the camera view, then you can bring that render window right back up and go back through the last rendered image. Unfortunately, there's no other sort of saving where you have layers or different versions of renders that are stored, so just the last render is the one that shows up. So the first format we're going to take a look at is bitmap. If we look at the bitmap and how it's saved, it is saved as an index. So if we go to image and mode, we can see index color. We also only have 8 bits. So if we were to go ahead and modify this, and what I'm going to do is just take Control L to open levels, or go to Image, Adjustments, and Levels, and just set this to Auto, which at the moment is pretty much making it black. So first let's go ahead and convert this over to grayscale. And it looks like we do have some depth that is not really showing up because so much of it is in white. So let's go ahead and just manually take that slider, and we can move that over. And now one thing we're seeing is a lot of grain. But for the most part, we have these very large slices in between the different depth zones. Closest to the camera is going to be the darkest, and farther away is going to be white. Now, by restricting and bringing in that lower level, what we've done is reduce the distance between basically the atmosphere and the last point of depth, or the terrain, which in this case wouldn't really matter because we would cut that out with an alpha anyway and have something else behind it. But for the most part, this ZDepth is very troublesome. And because it is automatically saved as an index file, it is also a little more difficult to work with in post. So if we open up another file, the next we're going to take a look at is the HDR. So working with a 32-bit RGB color format. Not much you can really see, because for the most part an HDRI image has so much depth that it is not displayed correctly. Not so much correctly, but just more difficult to see the amount of depth that's in the scene. So do the same thing as before, where I'm just going to auto level it. Now, once again, because of the distance between our furthest geometry and the atmosphere, we have that white spike showing up, all the way at the end of the histogram. So what I'm going to do is just manually type in a value of 20 and just bringing that right up to where that geometry begins, not really worrying about the atmosphere itself because that's something that would be really easily cut out with the alpha. But already you can tell that there is way more information in the depth. Now, we don't really need to have an HDRI image in order to use this information because we have an 8-bit amount of depth within the overall image, and just making it 32-bit was able to take that very tiny area that I originally saw in the histogram and expand on that without losing a whole bunch of detail. So if we switch back and forth between the two versions, you can see such a huge difference between both quality and the amount of depth. So what we can even do now is convert this image mode over to, well, one thing we can do is grayscale, since we certainly don't need any color. And we can go back to those options and change it over to 8 bits. When you're converting from a 32-bit to 8-bit or 16-bit image, you're given a couple of options where you can change the exposure and the gamma. Since we made modifications to the image with the levels, we certainly do not want to adjust to the exposure setting because one will lose a lot of information from the image. We're going to start to cut out a lot of the depth. Gamma, however, can be changed without a major impact, although it will adjust basically the depth and distances between the geometry. So I'm going to leave that at a value of 1 and click OK. So now we have an 8-bit image. Looks incredible compared to the original indexed color. So if I was to go ahead and copy and paste this into the same document, we can take a look at compare, and clearly you can see, I mean, obviously the noise is a big issue because of the way the conversion was and the closeness of the plants, and then compared to the HDR. And that's also because these leaves have holes in them, kind of where they've been eaten away by various insects, and that's part of the transparency map. So instead of that showing up as complete insanity, it looks really good. Now, for a still image, that's pretty good. Be able to use an HDR. Not really going to have to worry about file sizes just because it's one image. But once you're using this for animation, those image sizes and the file sizes are going to become a problem. And also, it will be a problem basically editing a composite layer as a 32-bit image because a lot of programs can't handle that. A lot of systems can't handle that. And really, it's pointless because that information isn't needed. We have all of the information that we had from the original HDR in this 8-bit image since we were able to condense the levels. So now I want to go back and take a look at some of the other formats we've saved and be able to take and see what kind of detail can be used from them. Because in HDR isn't always the best. Even though it has the most information in it, it's not always going to give you the most detail. The next format I have open is the PNG format. And this is an extremely useful format because of its file size, but unfortunately lacks the detail needed for ZDepth. And if it's a fairly basic scene or limited amounts of adjustments are needed, then it is definitely an acceptable format. But unfortunately, we'll run into the same problems as the other 8-bit images. If we open the levels once again, and just kind of bring that in, you can see we don't have nearly enough detail, not compared to the other image. I also want to note that working with levels in index mode, as opposed to converting to grayscale first and then modifying, and we'll do that without the auto just so you can see. Then we notice that grain, that very harsh grain in there. So by keeping it in the index mode before making or while making the adjustment, it'll keep the color a little better. But it's basically going to look the same as the original 8-bit we looked at, which was the bitmap. So we'll close that out.